Okay, in this activity, we're going to be dealing with another contingency table. In this scenario, we are looking at a college class, at a commuter college. We have information about the number of males and females in the class, as well as how many own their home, rent, and how many are living with their parents. Okay, in your notepad, I've created the chart here with all this information, but I've kind of prompted you with an open column here at the end and a blank row here at the bottom to kind of prompt you that you're going to need to come up with each of the column totals here as well as each of the row totals here. Both your column, I guess this would be your row totals, and these would be your column totals, should sum to the same number. In this case, it's going to be 38. We need these totals in order to calculate our probability, because our probability is a portion of the total. Okay, the first one we're going to be dealing with is what is the probability of selecting one student from this class who is a male that owns his own home. And at first glance, we're a little bit lost here because we don't see and or given, and those were those tip words there that we covered and talked about in class. But if we look at this word that, we are looking for a student who is a male that, or and, owns his own home. So this student, we're looking at the number of students that meet this whole criteria, both the criteria of being a male and own their own home. So we look at the row of males and we look at the column of owning our own home. We're looking at, we have 3 individuals who meet both of that criteria of being a male and owning their own home. So 3 out of 38 would represent the probability of males who own their own home. We're looking at the number of females who own their own home. We would be looking at, again, the row of females, the column of owning, and we see that we have 2 females out of 38 that own their own home. What is the probability of selecting one student from this class who is a male or someone who is renting a house or an apartment? Now there's 2 ors in here, don't let that kind of throw you, but we have a much bigger pool because we could have, the persons could be male, they could own or rent, or they could do both. And so that would be a much bigger pool of people. So when we look at the row of males, we have a total of 20 out of the 38 that are males. That's how we get this ratio. And then when we look at the column who are renting, we have a total of 19 renters out of the total of 38 that are renting. Now we're subtracting 12 out of 38 because when we look back up here, we look at the row and the column that we spoke of, we see that 12 is that overlap. That 12 is being counted both in the row of males as well as the column of renters. It's being counted twice. And so we're going to have to remove one of those replications so that we have an accurate probability. So that's why we're removing 12 out of 38 to get that probability. What is the probability of selecting one student from our class who is male and is renting? This is almost the same darn thing that we had above, but we're looking at and. That is that overlap. This overlap here between our renters and the males in the class. There are 12 out of 38 that meet both of those criteria, and that's a much smaller pool, and we can see that there when we look at our probabilities. For the next one, I need to slide it down here without losing our chart. What is the probability? I think I can go a little further. What is the probability of selecting one student that is a renter given that the student is known to be a male? Now that's that key word that tells you we are looking at conditional probability. Another word would be if it is known that the person is a male. So we are going to just look at the row of males. We have a total of 20 males again, and we want to know how many renters out of those males. So we have 12 out of 20 renters who are male. Again, that conditional probability filters the field. Okay, what is the probability of selecting 2 females from this class without replacement? So this is kind of backing up to something we've done earlier. Without replacement, we're going to be looking at the multiplication probability rule. We have 18 females out of the total of 38, so once you've selected one, we have 1 less female and 1 less total, so our next probability would be for that second chosen female, probability of getting a second female would be 17 out of 37. So we take the product of those 2 events. When we have replacement, we're going to make a selection, put that selection back in, and then select again. So we'd have 18 out of 38, our original, but that's going to be repeated. And so we can see our outcomes are slightly different. So when you have a small sample, with or without replacement can make a difference. Okay, I'm going to slide down out of this. Keep in mind we had 18 females and we have 20 males. Okay, so I'm going to slide down so we can see the rest of this. Okay, what is the probability of selecting 2 males from this class without replacement? We said we had 20 out of 38. Once we've made a selection, we have 1 less male, 1 less total, so our second probability there would be 19 out of 37. Multiplication rule, we're going to take the product of those two events to come up with this probability. Okay, with replacement, again, we're doing 20 out of 38 twice because we're going to put that first selection back in after we've made that when we go to make our second selection. So that would be another way that you could write that replacement probability. Okay, what is the probability of selecting 2 students from this class without replacement and getting 1 male and 1 female? Now, it doesn't specify whether or not the male is first and the female is second, or if the female is first and the male is second. And we need to recognize those are 2 different events. So when we look at the number of males out of 38, if we assume the male is going to be first, we'd have 20 out of 38. Our second selection, we still have 18 females in there, but we have 1 less total, so we'd have 18 out of 37. And again, we're going to take the product of those 2 probabilities. But if it's a scenario where we have the female first, our first probability would be 18 out of 38. And then if we're selecting male for the second one, there are 20 males in there, but we have 1 less total again. When we take the product of those 2 probabilities, we can see we have the same thing. Because when we look at the numerators, it's still the same product of 2 different numbers, but in a different order. But remember, these are 2 separate events, and so we are trying to identify the probability of getting 1 male or 1 female. It doesn't matter the order. We will take the sum of those 2 things. So here we're using our addition rule of probability. Okay, so for the last activity, check the probabilities for all selections without replacement. I'm looking at both female, and I get that from right here. And again, this was without replacement, so I'm just snagging that from here. Both male, I'm going to snag that down from here. And then male first and then female, and female first and then male are just that problem that we've just completed. So we add all those up, we should have the total sample space.